Now let's move on to metric units and measurement. We're still on page 13 in your spiral. Unfortunately, the US and Liberia are the only nations that use the English system of measurement. So you may be accustomed to yards, especially like when we're talking on the football field, miles, if we're driving and talking about distance, quarts, gallons, teaspoons when we're measuring quantities of food and drink, and inches when we're measuring small distances. An international committee of scientists decided that we should really have an international system to convey all scientific data. We call this the SI, base units. Why should we have an international system? Why does it matter what everybody else is doing? In your spiral, I want you to copy down the most common units that we're going to be measuring in lab. We'll write down the quantity on the left-hand side and the base unit on the right-hand side. Let's start with time. Time is measured in seconds, and I want you to write the abbreviation as well, SEC. Our units are going to be very, very important as we start manipulating and converting our measurements. The second measurement is length. We measure length in meters, and our abbreviation is a lowercase m. Mass is measured in grams, the lowercase g. Volume is measured in liters with a capital L. Temperature is measured in Kelvin with a capital K. And the amount of a substance is measured in moles, abbreviated MOL. The mass of one paperclip is a whopping 1.4 grams, about 1.5. How many paperclips would it take to match your mass? Now I want you to think about this. If a paperclip is equal to 1.4 grams, how many grams do you think you weigh? It would be a challenge to use such a large number when performing calculations. So if I was using the number of paper clips that represent our mass in grams, we're looking at a number with lots and lots of zeros at the end. How can we solve this problem? How can we make our calculations in chemistry easier when we're using numbers that are either really, really big or really, really small? Any ideas? Now, if you looked ahead in your notes, you might have seen the answer is prefixes. Prefixes allow us to work with simple numbers as opposed to very large or very small numbers. It does make our math quite a bit easier. And if you weren't aware, we do quite a bit of calculations in chemistry. We're going to be using our calculator almost every single week in class. So prefixes like giga, mega, you've probably heard these before, like gigabytes or megabytes. Kilo, hecto, and deca, they all are for very large numbers. Deci, centi, milli, micro, nano, pico, and femto are all prefixes for very, very small numbers. So to review, we're going to use prefixes to help us with numbers that are very big or very small. Write the following mnemonic device into the prefixes tab of your spiral. King Henry doesn't usually drink chocolate milk. And if you have a different color pen or pencil, I want you to write the corresponding prefix under its matching word. Kilo, hecto, deca, base unit, deci, centi, milli. As a reminder, our base units were meters, liters, grams. We just wrote those down on the previous page. And we can add these prefixes to our base unit like kilometer or kilometer, which makes a number very big or a measurement very big. Or I can add milli to the front of that prefix millimeter, and that makes that unit very, very small. So a quick comparison. I want to make sure that we're comfortable with what we're doing here. As I move from right to left, each prefix is 10 times the previous prefix. So as I move from milli to centi, a centi, I'm going to keep using meter, a centimeter is 10 times bigger than a millimeter. If I move from centi to deci, deci is 10 times bigger than centi, but let's compare deci to milli. it is 2 jumps, or 2 of these times 10. So a decimeter is 100 times more than a millimeter. Let's keep going. From deci to just a meter, from decimeter to meter, that's another increase of 10 times that value. So what if I were to compare a meter to a millimeter? If I were to look at all of this, it looks like a meter, 3 of those 10s, 1 meter is 1,000 times. You see how I'm just adding another 0 every time? It is 1,000 times bigger than a millimeter. What if I look at the process over from the left-hand side instead of the right? What if I were to compare a kilometer to a meter? And what do those values look like? Well, from meter to kilometer, that's 1, 2, 3 jumps to the left. Now remember, each jump represents 10. There's another 10, and there's another 10. So if I look at all 3, it looks like a kilometer is 1,000 times bigger than a meter. So each jump represents times 10, or moving of the decimal by 1 place. So let's write a few equivalence statements. These are statements of numbers that are equal one to another that you'll want to have memorized for our next practice session. I want you to start by writing 1 kilometer. 1 kilometer, and this can go right underneath your prefix. Now, if I have 1 kilometer, I want you to think that's similar, not exactly equal to, but similar to the distance of a mile. If I have 1 kilometer, how many meters would that be equal to? So now I'm going in this direction. 1, 2, 3. I know I'm going to have 3 zeros in that number. 1 kilometer is the same as 1,000 meters. Think of a meter stick. A meter stick is about the distance between both of your hands if you stretch them out. So if you do that 1,000 times, you have the same distance as 1 kilometer. Let's keep going. What if I have 1 meter? And I want its equivalence in millimeters. So again, I'm moving over in this direction to the right. 1, 2, 3 places to the right, 3 zeros. 1 meter, think again meter stick, about the distance between your arms if you stretch them out. How many millimeters are in 1 meter stick? And 3 jumps equals 3 zeros. 1,000 millimeters. Now we're going to get pretty fancy here when we start using our calculators, and 1,000 is the same as 10 to the third. So we're going to use exponents to make putting these numbers in the calculator just a little bit easier. So if you see 10 to the third, that's the same as 1,000 for us. Now the last equivalent statement that I want you to write down is from the meter to centimeter. That's another common conversion that you'll see. Let me erase some of this because we've got a lot of stuff going on up here. And let's count jumps from our meter here to the centimeter. That's 1, 2 jumps. Remember, the jumps are equal to zeros or decimal jumps. So if I have 1 meter, how many places or zeros do I need to add to my 1 meter to get the same value for centimeters? That's 2. I'll write it as 100. The same as 10 squared if we're looking to use exponents in our values. So before we move on, you have your mnemonic device written. You have the accompanying prefixes. We know that kilo, hecto, and deca all make a number bigger, whereas deci, centi, and milli make a measurement smaller. And we've written down these 3 equivalence statements at the bottom. Let's try 2 examples together. Convert 1.75 meters to kilometers. We're going to follow a systematic approach to solving all math problems in chemistry class. We're always going to underline our starting measurement, 1.75 meters, and we're going to put a box around the final measurement or unit that's needed. Because in math class, we put a box around our answer. So when we put a box around our answer here, it should be in kilometers. It should match. So here we go. I'm going to rewrite my number, 1.75. Now I'm going to use this jump method to move my decimal over to write an equivalence statement. So remember, it was King Henry doesn't usually drink chocolate milk. And here's why I don't write the full words out, I just do the letters, it helps me. Now I'm going to find my starting place. I am at the base unit, I'm here, I am at meters. And I need to go to kilometers, which is way over here. So I'm going to count my number of jumps. I'm going to move to the left 1, 2, 3 places to the left. So I'm going to take my decimal and I'm going to do the same thing in my number. I'm going to move it 3 places to the left. So here's my decimal right here. I'm going to move it 3 places to the left. 1, 2, 3. Now at the end, I'm going to put my new decimal and I'm going to fill all of these jumps in with zeros. So I'm going to put a 0 there and a 0 there. And now I'm going to clean this up. 1.75 meters is equal to, or the same as, and let's rewrite our number. I always put a 0 in front of the decimal because it helps me see it in case my decimal is too small. It helps it stand out. 0.00175 kilometers. Now notice that I not only put the number, but a unit next to each of my values as well. So let's look at this equivalent statement and see if it makes sense. 1.75 meters. So that's about 2 meter sticks. So about 2 distances between your arms if you hold them out. Think about kilometers. Those are similar in distance to a mile. Now, the distance between our arms is not very long. Does this make sense that 1.75 meters is equal to a really small number of kilometers? And your answer should be yes. Remember that kilometers are 1,000 times bigger than meters. So if I want to write an equivalent statement, 2 values that are different numbers, but because of the unit that's placed after them, meter and kilometer, it makes those values equal one to another. Let's try again. What if I have 0.87469 kilometers and I want to convert them to millimeters? So kilometers, similar in distance to a mile, and millimeters, those are those tiny itty bitty lines on that meter stick. So if you think about it, if these numbers are going to be equal, measurements equal one to another, how many millimeters should I have to have the same number of kilometers? So let's look at our mnemonic device up here. Our base unit is still the meter, so I'm going to put my meter there. My starting point in this case is the kilometer, so I'm starting all the way over here. And I need to go from kilometers to millimeters. So let's start jumping and count our jumps. 1, 2, 3, 4, 5, 6. A millimeter is 6 times smaller than a kilometer. So if I want to set these values equal to one another, I need to move my decimal 6 places, and look at my arrow, it moved to the right. I need to move my decimal 6 places to the right. So if I rewrite my number, 0.874569, you'll have to bear with me with my writing here. And if I take my decimal and I move it 6 places to the right, let's count. 1, 2, 3, 4, 5, 6. I'm going to plant my decimal here at the end of the number. So if I wanted to write an equivalent statement, 0.87469 kilometers is equal to 874,569 millimeters. And I didn't write the first measurement just because it's a little bit challenging to write on this screen, but I want you to see that these two values are equal one to another. So 874,569 millimeters is the same or equal to 0.874569 kilometers.